In this video, we're going to go over another way to measure the size of an angle that is in addition to using a degree symbol. So this other system is called radian measurements, and I'm also going to show you how to convert between those two, radians and degrees. Before we go on to look at the conversions between degrees and radians, I just wanted to give you a reminder that the process for converting units is the same no matter what kind of concept you're working with here. So I thought I would go back over that you can convert the units in a problem if you multiply by any conversion fact that relates to two units and you set it equal to 1. For example, I'm going to do some problems to convert from hours to minutes, from feet to inches, and from inches to feet. So for the first conversion here, I have 2 hours, and I went ahead and I put all the examples that I'm going to show as fractions over 1, just to make sure that you don't mistakenly multiply the 2 hours by the numerator and denominator of the other fraction. So remember, any whole number you have counts as being over 1. Now the conversion fact I'm going to use to go from hours to minutes is that there are 60 minutes in 1 hour. Now I need to put one of those numbers on top and one of them on the bottom, and we always want to make sure that our units are canceling out, so sometimes it's best to focus on what you already have in the numerator and put the same unit in the denominator of the other fraction. And I said that there are 60 minutes in 1 hour. So this would be the multiplication I would set up if I wanted to convert between these two things. This would make the hours units cancel. So then I can just multiply my fractions across. 2 times 60 gives me 120. And on the denominator, I have 1 times 1, so usually we wouldn't write over 1, but again, I just wanted to make sure people didn't accidentally do 2 times the denominator of 1 as well, so I now know that it's 120 minutes. For the next example, I have 5 feet, and the conversion fact to go from feet to inches is that there are 12 inches in a foot. Now again, I don't know which one goes on top unless I look at what I have in the numerator of the fraction for the 5 feet in this case, so I want to put the 1 foot in the bottom, and then 1 foot is equal to 12 inches. So again, it's very important that my fraction equals 1. 12 inches are in 1 foot. That's what I mean by saying the conversion fact is equal to 1. Otherwise, we would be changing the value of our fraction. Multiplying by 1 does not change the value of anything. So here I am multiplying my fraction straight across. 5 times 12 is giving me 60. And in the denominator, again, I have 1 over 1. So usually we just leave that off and just say that we have 60 inches. And then the last fact, this is the same conversion fact, but I wanted you to see the importance of paying attention to which unit should go on top or bottom. So now I'm going backwards from inches to feet. So I'm still going to be using the fact that there are 12 inches in 1 foot, but this time I need to make sure that I put the 12 inches on the bottom and the 1 foot on top. So as before, my units are canceling out. I have inches in the numerator and denominator of the fraction. They cancel just like any other number would. So when I reduce this, I end up with 30 over 12, which you might notice that these are both numbers divisible by 6. So kind of the same way of reducing the fraction. If I divide this by 6, I get 2. And if I divide this by 6, I get 5. So my answer is that I end up with 5 times 1 over 1 times 2. Feet, or 2.5 in this case, if you wanted to do a decimal instead. So this process of finding a conversion fact where you have something on the numerator and denominator that are equal to each other but using different units, this is the process we're going to use for converting between radians and degrees after I show you what a radian exactly is. So a radian is the angle measurement in a circle where the arc length is equal to its radius. So what I'm trying to show you in this diagram is pretend for a second that we had a circle with a radius of 5. Well, if the distance from the center to the edge is 5, I could also try to measure a distance of 5 going around the outside of the circle. So if I made this length and the radius length equal to each other, I would end up with an angle inside of this piece. And that angle is what we call exactly 1 radian. Now, it might seem like a very strange thing to care about the angle where the arc length is equal to the radius, but it does come in very handy when we start doing a lot of our calculations with unit circles and rotations around circular objects. So that's why we use a radian. And the important conversion fact here is that 1 pi radian is going to be equal to 180 degrees. So when we're doing our conversion, it's always going to be 180 over pi or pi over 180, depending on which way you're converting. So if you're going from the degree measurement to the radians, multiply by pi radians over 180, because you want the degree symbols to cancel in the denominator. If you're going from radians to degrees, then you want to have the pi radians in the denominator so that the radian units cancel. Now, radian measurements usually have a pi in them, but there are some exceptions you might see. It's just like 98% of the time, I would say, there's a pi in your answer, which you'll see on the examples I'm about to do. But don't assume that there will always be a pi in your radian answers. It is possible to just have a decimal value instead. Okay, so these are all degree measurement angles, and these are what you're probably more familiar with. So the first thing I want to do is remind us that this is counting as over 1 for a second. My conversion fact is that there are 180 degrees in 1 pi radian. So the degree symbols cancel out just like any other unit does. So if the degree symbols are gone, I can just reduce what is 90 pi over 180. And you could also even ignore the zeros, in fact, and just think of it as 9 over 18 if that's easier for you. So this ends up being the fraction pi over 2 radians. Now, this is an angle that we will end up using a lot. So I think over time, you'll just start to memorize that 90 degrees is pi over 2 radians. In the same way that we've spent a lot of time working with triangles that have 90-degree angles in them, you're going to start to see that we have a lot of circles we work with that have a pi over 2 angle measurement in them. Okay, next example, it's going to be the exact same setup. You might want to think of this as being over 1. And so I'm multiplying by 1 pi radian over 180 degrees. So the degree symbols will cancel. You would have 270 pi radians over 180. Again, you can ignore the zeros if you want for a second and just think of this as 27 over 18 if that makes it easier to work with. So this one is 3 pi over 2. Both those numbers are divisible by 9 in this case. So 3 pi over 2 radians. And then the last example, we can also do this with negative angle measurements. So if I have negative 135 degrees over 1, I'm going to think of this as multiplying by 1 pi radian over 180 degrees again. The degree symbols will cancel, so you'll have negative 135 pi over 180. And this time my numbers don't both end in zeros, so you might need to reduce this a little more deliberately by saying like, well, they are both divisible by 5. So if you recognize that they're both divisible by 5, you can break this down first as negative 27 pi over 36, and then recognize that these numbers are both divisible by 9. So you can break this down again as negative 3 pi over 4. Okay, the questions look very similar, but this time we're converting from radian mode to degree mode. So this time if I have a measurement that's in radians, we're going to have to flip the order of the fraction I'm multiplying by. So now I'm going to have the 180 degrees on top, and the 1 pi radian goes on the bottom. As with any other number, if I had 5 on the numerator and denominator of the fraction, they would cancel. Well, the same thing happens with the pi's. So if the pi's cancel out, that leaves me with 180 over 3. And then we can reduce this fraction to get 60 degrees. Next example, we have negative 3 pi over 4. It's going to be the same process every time. So converting the units, I'm going to multiply by 180 degrees over pi. So the 1 pi radian pieces would cancel. And then we can multiply this out to get negative 540 divided by 4. Oop. And then this fraction reduces as well. So then this one ends up equaling negative 135 degrees. And one last example, same idea. I am going to be converting. So to get the pi's to cancel, I need the 1 pi radian in the bottom, and I need the 180 degrees on top. The pi's will cancel. This is a case where honestly it would be easier before you multiply the numbers straight across. You might want to recognize that the 6 and the 18 are both divisible by 6. So if you divide the 6 into both of them, then this actually comes out to 30 degrees. And so 5 times 30 gives me 150 degrees. If you want to multiply 5 times 180 and then divide by 6, that's the same thing. But if you don't have a calculator handy, it's helpful to know little tricks like that. And for emphasis on this, I was only canceling out the 18 part, not the whole 180. So it was very deliberate that I only marked out the 18 piece to make that 3 for 6 going into 18 3 times. So then I just did 30 times 5 is 150. So that's it for the notes on what a radian measurement is and how to convert them. I think over time, you're going to start to just memorize a lot of the same angles you already know, like 45-degree angles and 30-degree angles. You're going to start to memorize those in radian form because we'll be using them so much in this class. But as a sort of last resort, you can always use this process to convert back and forth between them as needed. Thank you.